All right, and welcome back for Unit 14.3, Charles' Law, Gay-Lussac's Law. So Charles studied gases and looked at the volume as it compared to temperature. And what he found is that volume and temperature are directly proportional. It's going to be important that you understand this relationship so that you know how to work with them mathematically. So a direct relationship means that as one goes up, the other goes up. So the image over here, we see a flame and a larger flame. So that's to show an increase in temperature. Our temperature has gone up from our picture on the left to our picture on our right. From T1 to T2, the temperature has increased. What that's going to do is it's also going to increase the volume. So here we have a smaller volume. As we increase temperature, we now have a larger volume. That's a direct relationship. Here's how we use it mathematically. So if a sample of gas occupies 6.8 liters at 325 degrees Celsius, what will its volume be at 25 degrees Celsius if the pressure does not change? Big important detail here, guys. You have to convert to Kelvin. You have to be able to do that every single time. We can't use degrees Celsius. So there's our value, our 273. Again, I like to list out my variables. You don't have to, but I'm highly, highly, highly encouraging you to do so. So our initial volume was 6.8 liters. They're asking for a second volume. What would its volume be? Our initial temperature was 325 degrees Celsius. That's quite warm. The temperature changes to 25 degrees Celsius. Again, for both of these values, we have to convert it to Kelvin first. So there's that conversion, the 273. Now the next thing I want to do is I want to think. Here's me thinking. What happens to my temperature? I went from 598, that's my T1, to 298. My temperature went down. So what do I expect to happen to my volume? I expect my volume to also go down. Direct relationship, when temperature decreases, the volume will also decrease. Okay, so I look at my two numbers, 598 Kelvin and 298 Kelvin. How will I get a smaller number? Do I want the big number on top or the smaller number on top? If I want to get a smaller value, I want to put the smaller number, 298, on top. 298 divided by 598 is going to be a fraction. It's going to be less than 1, and that's how I'll get a smaller volume than 6.8. So I want to put my smaller number on top, the larger number on bottom. I multiply through, and I get a final volume of 3.39. Again, I want to double check. I want to think, am I doing these problems right? I expected my temperature, when my temperature dropped, I expected my volume to also drop. Hey, I've got a smaller volume. Looks like I did it correctly. That's Charles's law. Next up, we have Gay-Lussac's law. So Gay-Lussac took a look at temperature. Again, here's that candle or that heater, and pressure. So let's assume this time that our volume doesn't change. We have a 1 liter volume on the left and a 1 liter volume on the right. It's important that we hold the volume constant because otherwise the volume will just increase when I increase the heat. So if we assume the volume is the same as we are looking at this picture, 1 liter and 1 liter, when we increase the temperature, the pressure will increase. Gay-Lussac also found a direct relationship, this time between pressure and temperature. So as we heat up these molecules, you can see they're moving faster. See the little yellow spheres, they have a longer tail. It indicates that they're moving faster, which means they're going to collide more often and with more energy with the surrounding sides. More often and more energy means a greater pressure. Again, it's going to be important that you remember and apply that thought, that direct relationship. So here's an example. The pressure in a sealed plastic container is 108 kilopascals at 41 degrees Celsius. What is the pressure when the temperature drops to 22 degrees Celsius? Assume that the volume has not changed. Again, that'll be important. We don't want to change the volume if we're measuring just the temperature and the pressure. Hey, once again, don't forget to convert to Kelvin. Again, I like to list up my variables. P1, my first pressure was 108 kilopascals. My second pressure is currently unknown. That's what they're asking for. My temperature, I've converted to Kelvin, 41 degrees Celsius, plus my 273 gave me 314 Kelvin, and 22 degrees Celsius plus 273 gave me 295 Kelvin. Again, I want to think this through. I'm looking for my second pressure. I'm starting with 108 kilopascals. Here's me thinking, from T1 to T2, my temperature went down. So I'm also going to expect my pressure to go down. Again, how is that going to be possible? Do I want the big number on top or do I want the little number on top? If I want 108 to decrease, I want to multiply it by a fraction less than 1. So I want to put my smaller number on top. 295 is smaller than 314. Now I have two values that are going to be a fraction less than 1. When I multiply 108 by 295 and divide by 314, I end up with 101 kilopascals. Hey, 101 is definitely smaller than 108. I think I did my math right. Again, it helps to know those relationships. So make sure you guys are memorizing pressure and temperature directly proportional. What happens to one will happen to the other. A couple more examples to work through with you. Exactly 5 liters of air at negative 50 degrees Celsius. And hey, here's why we want to make sure we're using Kelvin. That negative symbol there, yikes. We don't want to have a negative pressure. Not even sure what that would be. So our 5 liters of air at negative 50 degrees Celsius is warmed to 100 degrees Celsius. What is the new volume if the pressure remains constant? All right, so our initial temperature, T1, is negative 50. We want to add that 273. We end up with 223 Kelvin. Notice we've eliminated the negative sign. Again, that's big. We don't want to have a negative pressure. We don't want to have a negative volume. I'm not sure exactly what those values would mean. Our second temperature was 100 degrees Celsius. Could we add the 273? We end up with 373 Kelvin. Our initial volume was 5 liters. We're looking for a second volume. I'm going to set up my factor label. My second volume is unknown. I'm starting with 5 liters. I got to think this through. My temperature increased. What do I expect my volume to do? So direct relationship, I also expect my volume to increase. So how am I going to get a larger value? Do I want the big number on top or the small number on top? I want to multiply my 5 liters by a number greater than 1. So I want to make sure my big number goes on top. 373 is larger than 223. So if I were to divide 373 by 223, I'd end up with a number greater than 1. That's good. When I multiply 5 by a number greater than 1, I'll end up with something greater than 5. And in this case, it's 8.36 liters. Another example, the pressure in a car tire is 198 kilopascals at 27 degrees Celsius. After a long drive, the pressure is 225 kilopascals. What is the temperature of the air in the tire? Assume that the volume remains constant. And I like to list out my variables, make sure I'm converting into Kelvin and carry that digit. It's an addition problem. I need to make sure that my last digit is in the ones column because both my values have significant digits in the ones column. So even though it's an even 300, I have to put that decimal there to make sure that 0 is significant. Here's my pressures, 198, and it increases to 225. So I set up my factor label. I'm looking for my second temperature. It's going to be in degrees Kelvin. Excuse me, not degrees Kelvin. There is no degrees Kelvin. It's going to be in Kelvin. We're starting with 300 Kelvin. My pressure increased. My pressure went up, so I'd expect my temperature to also increase. Pressure and temperature are directly proportional. How do I get a number greater than 300? I have to make sure that I multiply it by the larger of the two numbers. So I put my larger number on top, 225, my smaller number on bottom, 198 kilopascals, and I'm going to have a number greater than 1 when I multiply 300 by a number greater than 1. I end up with a number greater than 300. That's what I'm looking for. As my pressure increased, so too did my temperature. Sometimes I might ask you to convert it from Kelvin back to degrees Celsius. If you do, not a big problem. Just subtract 273 to get to degrees Celsius. Here's your homework for this evening. Take a look, give it a shot. Don't be afraid to list out those variables. Yes, it takes a little more time, but isn't your grade worth it? I think it is.